Hi, this is a short series of videos that's going to help you to revise or check that you've understood most of the things that we went through in the first 3 weeks in Java. Um, this is the Java, it's called a complete tutorial for IB. I made it kind of to your specification for the course, and it links together with this, which is the first steps in Java challenges. So you can go backwards and forwards between the two documents, and it should explain how to do things in the challenges as you face them. Okay, so I'm going to jump forward. One of the first things that we learned about was primitive variables. Remember, primitive variables, there are 8 different types. That's them on the left-hand side here. And most of them are either whole numbers or decimal numbers. There's a couple of other funny ones, but let's deal with those first. An int is the main one that we will use, and it's a whole number. But if you want a slightly larger number, which occupies twice the size of memory, you can choose a long. Now there are other whole number types. There's a byte and a short, which are significantly smaller. The byte only stores values from -128 to 127 positive. Not used very frequently. Similarly, a short from -32,768 to +32,767. Now, I'm not looking for you to remember those exact numbers because you'll be able to calculate those numbers later on when we do binary arithmetic. You'll be able to calculate them by the size of the bits. So I'll show you how to remember that later on. But what I do want you to know is for these different types, what might they be used for? So let's go through quickly. Normally we'd use an int for whole numbers, a long for larger whole numbers, a float for normal decimal numbers, and a double for very, very large decimal numbers with extreme levels of accuracy. Okay, now the other 3 that are left, a byte is not used very frequently, but it could be used for if you're storing a huge amount of very small numbers, because then it would save space. I mean, if you've what we call an array, if you have a huge array of very small numbers, you would use this because it would save storage space. I'm talking about if you're storing thousands of numbers. A char, this is one character, and it's used internally inside the string class. It's what makes up a whole string, an array of these chars. Each one is one position in the string. But if you just want to store one letter, it can be useful. And the final one is a boolean. This is used very, very, very frequently. And if something can be yes or no, true or false, it only has 2 possible states. Generally, we would try and use this because it's very, very handy and very neat when you see it in code. Okay, a variable needs to be declared and then initialized. Initialized means you give it a value for the very first time. You assign a value for the very first time. Declaring is when you say what type the variable is, and initialize is when you give it its very first value. So if you look at these examples, only 3 of them are initialized. You see the equals after it. It's given a value, this is given a value, and this is given a value. That means that these 3 variables are initialized, whereas the other ones are just declared. See that? Float int val, int ret val, double gamma. However, these are also in the same line as int, so these are also declared. So this variable here has been declared. This variable has been declared. This variable has been declared and then initialized. This variable has been declared and then initialized. This variable has just been declared. This variable has been declared and initialized. So you may need to look at a couple of different ones and tell me which combinations, whether something has been just declared, initialized, or whatever. In certain situations, Java will allow you to use a variable even if it's only been declared and not initialized yet. And those circumstances are, for example, if you declare a huge array of those values and you don't need to do every single one. So for example, if I have a massive chessboard which is 500 spaces by 500 spaces, and I store a variable in each one, a structure like that, I store a variable in each one of those, a number, then I don't necessarily have to set them all to 0. Java will do that for me. But let's just imagine now that if you don't initialize these, Java will give you an error, because that's what's going to happen in 99% of the cases, okay? So last look at this, declarations. This is an integer and it's been set to 1.2, so that will give you a compiler error. That's wrong because an int is a whole number. This is a boolean, a true or false, and it's been set to 1, so that will also give you a compiler error. This is a double value, which is a long decimal value, and it's been set to two whole numbers, two integers, one divided by the other. Now this will not give you an error, but the answer is going to be a bit strange, because whenever you divide a whole number 5 by a whole number 4, the result is going to be in a whole number as well. The result is going to be 1, because 4 goes into 5 once. That would be the whole number answer. And so therefore 5/4 is going to be equal to 1, which is not what you expected. The proper way of doing it would be if you divided 5.0 by 4.0, and then the answer would be 1.2. Now another way of doing that is, instead of just putting those values in there, if you define a double variable as 5 and a double variable as 4, and then divide one by the other and put it in here, that will also give you the correct answer. It's only when you're using direct values in code like that that you need to be a bit careful. You can also put an F after the value, which tells Java this is definitely to be stored as a float. So you might see that in code sometimes. I'd advise you just to do it with decimal points. Final one as well, just so you remember, a float is accurate to about 7 decimal places and a double 15. And finally, assigning the variables. If you want to, you can do something like that, or you can even do something like that. Just to kind of work this out from left to right, if A is 1, B is 2, and C is 5, then if I work out this statement from left to right, A is equal to B, so A is now 2, B is equal to C, so B is now 5, so that would become 2, 5, 5. It's a bit of a trick question. I don't think you'd ever get that in an exam.